Good morning, children. This is lecture number 3, chapter name Electricity, page number 204 to 205. Today, we want to discuss basically on 3 topics. One is the direction of electrons and the conventional current. Second, recapitulation or recalling the topic of PD and resistance, and verification of Ohm's law that we have already understood in the last lecture about Ohm's law. We'll take it in a more clear way in this lecture. Let me be more clear about all this content in this lecture. Now let's take the first topic. It's called direction. You can see the direction of electronic current, that is electrons, and direction of current, that's called conventional current. Please refer this diagram properly. This is the cell that we have connected, source of electricity. There are the electrons in them. This is the resistance that we are connected to it. So when we switch on the current, these electrons starts flowing from negative terminal to positive terminal, because electrons have a negative charge, so they will be attracted towards the positive terminal. So as soon as we start the circuit, start the current, these electrons will move from negative terminal to positive. As a result, the current will start flowing in the circuit. This is a closed path where the electricity is moving. So you can easily see the direction of current here. So what we see, the direction of the electronic current is from negative to positive, and the direction of current, conventional current, is opposite to it, that is from positive to negative, that we can see here. The current is flowing from positive to negative. So we can make a conclusion that direction of electric current is from negative to positive, please note, and direction of conventional current, that is actual current, is from positive to negative. That is, the direction of electrons are exactly opposite to the conventional current, or vice versa. The conventional current is exactly opposite to the electrons. My dear children, please understand this topic properly, because the direction are asked. You must be clear about the direction of current basically. So the direction of the current is always from positive terminal to negative terminal, not from negative to positive. This direction is to be most clear to everybody, because this flows from positive to negative. Please understand this one. I hope this content is clear. If it is not clear, please WhatsApp me or can converse me in telephonically also. The given number to you if you have any problem regarding this thing. Now let's come to the recalling of PD once again. Now everybody can see this topic has been already discussed in the last lecture. PD is equal to V is equal to W upon Q. So in the last 2 lectures we have already discussed about all these things. We again take the definition of 1 volt here. So PD is given value of 1 volt here. Work is given 1 joule, because work is measured in joule, so we are putting 1 joule, and charge is measured in coulomb, so we are putting it 1 coulomb, right? So 1 volt of PD is a ratio of 1 joule upon 1 second, but this should not be defined in this way. It should be defined in this way: 1 volt of PD, potential difference, is produced when 1 joule of work is done to move 1 coulomb of charge from one point to another. If you remember the definition of PD last time, we discussed that it is the amount of work done to move certain amount of charge, unit charge from one place to another. So you have to just put the value in this. How much work is done? 1 joule. And how much charge is moved? 1 coulomb. So the definition becomes more clear here. For 1 volt, 1 volt of PD is produced when 1 joule of work is done to move 1 coulomb of charge from one point to another. I hope this definition should be also clear to everybody. Any doubt should be informed to me in my WhatsApp number, and go through the modules in FlipLearn application also if you have access to it, and go through the more concepts. These concepts are given in more clearer than this, so you can see those modules, you can understand them more better. And if you have still any doubt in the modules, also you can discuss to me telephonically, or you can give me your queries in WhatsApp number. I've already given you the WhatsApp number in the last lecture. You can give me your queries in WhatsApp. Try to go through all these videos 1 or 2 times at least, looking into the things more clearly, and please find it that no doubt should be in your mind regarding all these definitions. So please understand one more thing. PD, that is called voltage, is measured by an instrument called voltmeter, which is always connected in parallels. About the series and parallel combination, my dear children, will come in the next videos, coming videos, because that needs little more clarification. How do you make the series combination or a parallel combination? That needs some time to make you understand. So please understand at this moment that this voltmeter will be connected in parallels. Ammeter already we discussed that we connected in series, right? Ammeter, which measures the current, is connected in series, and PD, which measures the voltage, the another name for the PD is voltage, measured by the voltmeter, connected in parallels. I hope it is clear again. So we move to the next page now. You can see the next topic that we're going to take is resistance. Once again, formula already we have discussed last time. According to the Ohm's law, R is constant. R is equal to V upon I. Please see this. R is equal to V upon I. By Ohm's law, R is constant, but despite I told you temperature should be constant. So if you put their units, ohm, you can see the symbol that we make like this. Ohm. You can practice this in your home by making like this. So ohm is the unit of resistance. SI unit of resistance. This, whatever the unit that we talk at this moment, is SI units. So SI unit of resistance. So by Ohm's law, R is constant. Putting all these units in one value, unit value. So R is measured in ohm. So it will be 1 ohm. Potential difference 1 volt. Current 1 ampere. So ohm is the unit of resistance. Please clear about all these things. Please see this video 2 or 3 times. Still if you don't understand, you can call me, or you can ask for any queries, any doubt which can be clarified by me. So 1 ohm definition comes from this particular formula. So 1 volt PD that we taken, and 1 ampere current that we taken. So 1 ohm is defined as the resistance produced or offered when 1 volt of PD across the resistor produced 1 ampere of the current, or vice versa. Vice versa means it can be in reverse also. That is 1 ampere of current produces how much voltage? 1 volt. That is, if you measure with help of ammeter, current is 1 ampere, how much PD will be produced? 1 volt. Please understand, this is totally obtained from Ohm's law. Both of them should be proportional. The values should be equal. So 1 ampere of the current, whatever the consequent PD produced is of 1 volt, your ohm will be 1, as well should be 1 ohm. So 1 ohm is defined as the resistance produced when 1 volt of PD across the resistor produce 1 ampere of current, or vice versa means reverse of that, 1 ampere of the current produce 1 volt of PD. I hope it is clear again. Please see this video 2 or 3 times and mark the important queries if you have, and you can ask me telephonically or give me your queries in my WhatsApp number. So again and again I am telling you, if you have any doubt, that should be clarified to me. Now let's come to the last topic, that is experimental verification of Ohm's law. How you are going to verify the Ohm's law? Now this is a simple circuit that you can easily see. We are connected the resistance with the voltmeter in parallels. This is the way that we connected in parallels. We'll be more clear about the parallel combination in the next videos. Parallel, you can see this is the parallel combination, and this is the series combination where ammeter is connected to measure the current. Now you can see the how many batteries cells we are connected in the battery. 3. So if you take one cell, you can show like this. If you take 2 cells, you can show like this. If you take 3 cells, you can show like this. It means you can take battery of 3 cells. If it is connected to 1 cell, the arrow will come here. If it takes 2 cells, the arrow will come here. If you take 3 cells, then it will be. So that is up to you how much cell you are using at a particular time. So what we are going to prove, we are going to take the value of R. The ratio you can see V is upon I, because V is proportional to I. So you have to see the values of V and I. Please understand this experiment properly. I'm just keeping this diagram in view. So we are coming to the next page now. Please understand, if you can keep this in your mind, you can make it draw roughly, because we don't have that particular diagram in the next page. So you can draw this diagram in front of you and then see this, how I am going to prove this. Now in the next one, what we have done, we have taken one cell. So if you take a one cell, your voltage will be 1, V1. So whatever the current comes in ammeter, that will be noted. You will find the value of R1. It means if you are taking one cell, your R1 value will come V1 and I1, that can be noted down from voltmeter and ammeter. That will be first conclusion. Now if you take 2 cells, if you are taking 2 cells, then value comes R2. If you take 3 cells, that is, when you are allowing only one cell, this value comes. If you are allowing 2 cells, R2, V2 upon I2, the ratio has to be calculated like this. So the 2 cell means, for example, if it is 2 volt, 1 cell, so how many cells you are taking? 2, so it will become 4 volt. Here it becomes 2 into 3, 6 volts. Here 2, 4, 6. 2 वोल्ट के लिए कितना करंट आएगा, 4 वोल्ट के लिए कितना करंट आएगा, 6 वोल्ट के लिए कितना करंट आएगा, वो ऑटोमेटिकली यू कैन नोट आउट फ्रॉम द एमीटर, यू कैन नोट इट डाउन हियर. For example, I'm just giving a value. For example, it comes to 2 volt of battery, and you have taken a current of 4. So if it is 4, for example, the value comes 8. For example, it is 6. It is, for example, 12. So if you cut it, it is 1 upon 2. If you cut it, it is 1 upon 2. If you cut it, it is 1 upon 2. Can you understand? These values have been noted down by taking either 2 volt cell, 2 cells means 2 into 2, 4 volt cell. This by taking 3 cells, 2 volt each, 6 volts. So you can note it down. And if you find that these values are coming constant, so what is the value coming here? 1 by 2, that is 0.5. If this value comes constant, then R remains constant and it verifies the R constant, and the resistance will be called ohmic resistance, and it verifies the Ohm's law. And by the Ohm's law, what is constant? R should be constant. Please see the graph also. If you take the corresponding value of V and I, if you take corresponding value of V and I, they are coming to be straight line. So we'll discuss this again in the next video once again to have a more clear concept. Don't worry, my dear students. We'll discuss this again in the next video. Please go through this properly in your NCERT book or in a full plan app. If you still don't understand, we are going to take this in the next video once again. So just go through this, and any queries, If any doubts you have, please WhatsApp me or ring me personally to this number. Thank you so much. Dear children, take a leave and try to learn properly. Thank you.